We might not email you when we grade the expansions. It might just show up in Autolab. But that's... I don't know when I'm going to start looking at the expansion objectives. It might not happen soon. I might not start looking at them until after the deadline, until after next Sunday. But as long as you did the expansion, you know it's working. But, I'm not going to get really strict with the grading. I don't like JSON anymore. JSON is a whole different animal in a strongly typed language. I'll tell you what. In JavaScript and Python, JSON is so easy. Once you move to strong typing, oh my goodness. A whole different animal. Hey, I'll say this again since it was brought up. When you go to interview, like when you do your LO5 interview, if you haven't done it already, like this has been on the syllabus since day one. Read these explain sentences. This is exactly what we're testing in that interview. For LO4, this is exactly what we're testing. For LO3, this is exactly what we're testing. It doesn't happen too often, but I'm surprised that it's non-zero number of students who come into an interview not prepared to talk about these things. This is what you need to talk about. Describe the structure of event-based systems, the mechanics of message passing, and what advantages these architectures provide over sequentially executed programs. And of course, the two applications of event-based architectures we talked about was actors and WebSockets. So you should be prepared to talk about those. Talk about this in context of WebSockets and actors. So there's no surprises. The specific questions might be a little catch you off guard a little bit. I'm surprised a non-zero number of students, when they come to me for, I'm doing the LO1, 2, and 3 makeup interviews this week, they'll come in for an LO2 interview, and I'll open with explain inheritance, and they'll be like, whoa, I didn't know you were going to ask me that. Like, yeah, I'm going to say explain inheritance, explain polymorphism, explain abstract classes. My follow-ups might cut you off guard. When I ask follow-up questions, okay, now based on what you told me, what would happen here? And that I understand. But what is inheritance should not catch you off guard. What is polymorphism should not catch you off guard. What's up, Slug Lovers? What's up, Liam? Let's get started. I opened the stream a little bit late, so I kind of lost track of time a little. We're 3 minutes in. Let's do this thing. Put a ring on it then. Yeah, I missed the conversation anyway. All right, let's do some slides. MVC, these are the last set of slides. I probably won't get through all the slides today. There's 2 slide decks that I can go through. So Monday I might have some more slides, which I don't know what to do with review when it's... maybe it will work better with chat than live, but usually I just say, hey, what do y'all want to review? I might create a Piazza post. I've done that before, just like I did it this semester. Like I did for Makeup Week, I'll create a Piazza post and say, what do y'all want to talk about for review week? So look out for that. MVC. We've seen this all semester. A few of you, if you've had MVC questions on your interviews this week, we are disregarding those questions. We had a little bit of a miscommunication. I intended to cover MVC during Makeup Week, but I never actually got to it in lecture, so we figured those questions were a little unfair. So we are scrapping those. If you got those questions in your interview, we are throwing those ones out and looking at your answers to your other questions. So just so you know. But MVC, let's talk about this. I use this structure in most of your homework assignments. So if you want to get examples of this architecture in action, then take a look at those assignments, take a look at the structure, and kind of look at them in this new context of the MVC architecture. So we've seen a design pattern earlier in the semester, the state design pattern, and there are many other design patterns that I obviously, of course, have not talked about in this course. But this is a little different than a design pattern. This is an architecture pattern, which tells us how to helps us organize our entire project. So with MVC, we organize the entire project into a model, a view, and a controller. These are the 3 parts, and we keep these parts completely separate from each other, and they only talk to each other through API calls. So each of these three pieces can have methods for the other two to interact with, but there's no inherent link between these. These are very what we call decoupled. They're decoupled from each other, and they work completely independently and might just ask the other pieces for certain information or send certain information to them through API calls. So we want to decouple the entire project into these three parts. So the API, I use this term a lot, and so hopefully this slide feels a little bit out of place, because hopefully by now you're like, I know what an API is. But just a refresher, because this acronym comes up very often in programming. It stands for Application Programming Interface, and we've seen them since 1.15. You developed web APIs, which gave you where you design certain endpoints of a website that people can connect to. People can connect to one API endpoint to get your HTML, another API endpoint to get the data that you were serving up for your project, and you had certain, like a list of things that users can use to interact with your web app. And in general, that's really what an API is a list of things that somebody can do to interact with your code in our cases, but not even necessarily code. We use this in the state pattern. The API was the list of methods that users are going to interact with our code. So for example, for calculator, the API was any of the buttons that the user can press. That's how the user can interact with our code. So anybody using our code, the API is what they can do to interact with it. It's usually, in our cases, a list of methods, but it doesn't necessarily have to be. Like the web API was a list of API endpoints that the web server is going to listen for. So the advantage of using an API is that how we actually resolve something, how we actually compute something, is completely up to us. As long as the API doesn't change, we can change what we do behind the scenes, behind the API. So, for example, in Physics Engine, the Physics Engine works through the update world method. Update world is the API of Physics Engine. That's the only entry point into Physics Engine. Everything else is internal details. So as long as we get a world with static objects and dynamic objects and a constant for the magnitude of gravity, as long as and the elapsed time elapsed since the last update, as long as we get all that information, everything else is up to the Physics Engine to do. There's no integration between, for example, Jumper and the Physics Engine when you worked on that homework, if you did that one. There's no inherent link between Jumper, the game, and the Physics Engine that Jumper uses. So this allows us to use the same Physics Engine in multiple different applications, as long as those applications use the API of calling update world. That's the only way that they interact with the Physics Engine. So now if we want to add new physics to the Physics Engine, say we want objects when two dynamic objects collide, if you build the expansion objective for Physics Engine and add dynamic collisions on top of the static collisions that was part of the homework proper, then Jumper, the game, now has dynamic collisions without changing a single line of code in Jumper itself. So if you did the expansion and you fired up Jumper again, you can see that two players can now collide with each other and they bounce off each other and interact with each other instead of just going through each other like they do before you code dynamic collisions. No change made to Jumper. It's still calling the API though, then behind the scenes behind the API changed. So this is very advantageous. We can get a lot of power out of our code and a lot of reuse out of our code by utilizing these APIs. And if we want to add, maybe we want objects to bounce in our Physics Engine. Maybe we want to add more features, more physics features, simulate momentum and things like that. We can add that to the Physics Engine and have it applied to all of our applications that use that Physics Engine. As long as you don't change the API itself, this is something, if you change your APIs, other programmers will get upset with you, and rightfully so. So if we wanted to add something to Physics Engine and we change update world to take another parameter that's non-optional, an optional parameter you can get away with, but a non-optional parameter, Well, now you just broke everything. You broke the jumper game because jumper's not giving you that extra parameter, and everything that uses that physics engine is broken now. Just like for grading, for every question I give you, I define the API in English, and then you have to implement according to that API. If you submit to Autolab with an extra parameter or a different name or something, you break that API. Then Autolab says, I don't know what to do with this, because it's expecting the API that's defined in the lecture question slides or the homework document. So we've used APIs throughout. They're used in a lot of different contexts. But hopefully that clears up a little bit more about what API is. Oh yeah, GUI. I don't know if sometimes I don't expand these acronyms. GUI, Graphical User Interface. I don't think I ever actually defined that acronym. A user interface, just the way that a user interacts with our code. A GUI is a user interface that's graphical, that we actually have visuals. So usually we have the command line interface, or a CLI. Yeah, here we go. We have a command line interface. That's what we have been using. We haven't taken user input through the command line, but we've outputted information to the user by printing it to the screen. But then we move to graphical user interface to get the more interaction with the user. All right, so with a brief history of API, not history, but a quick reminder of, Jesse, what's my name an acronym for? Ooh, that's a good question. So with that quick reminder of APIs, let's talk about MVC proper and talk about these three pieces. I'll go briefly over them here, and then I'll talk about each one for at least one slide following this. So the model is what actually does the work of the app. This is what, if you could pick one of these three things that is the software that is the app, my vote would go to model. This is the real core of the processing and the logic and handling the data, really doing all the work for the project. For most problems, most code that you've written so far, at least for assignments in 115 and 116, most of it was working on the model. So for the homeworks, I would give you the view and the controller, and then you would have to write the model. The model is where all the action happens. That's where the interesting bits happen. At least for me. You might have different opinions. If you're a more visual art oriented person, you might say the view is the app. So the view is everything that's displayed to the user. It takes the current state of the program from the model and displays it to the user. It has no other job than displaying the current state of the program to the user. And that's it. So the model will have a way to give up the state, to send the state to the view, and the view displays it. Purely an output portion of code. And then control, this is purely an input portion of code, is going to get inputs from the user and convert those inputs into API calls that go to the model. So the model is going to handle API calls, or is going to have an API that the controller is going to call when the user takes an action, and then the view is going to display this updated state of the game to the user. So those are the three parts of how MVC works. In UX, to go with our acronyms in chat here, user experience. The user experience is, of course, an important part of software. But that's what that acronym stands for. And the real master's right, that's part of what UX is. So visually, we have a user. The user is consuming the view. That's how we communicate to the user. User inputs, hitting the keyboard, clicking the mouse, moving the mouse around. That's how the user is interacting with our software. And then the controller takes these user inputs, keyboard inputs, mouse inputs. The controller, to put it in context of our examples, is usually where we have listeners. If we have a listener, that's part of the controller. It's going to listen for those inputs, convert those into calls to the model, and send those commands to the model in the form of API calls. And the model is going to have an API, like for calculator or for microwave. The number 1 was pressed, the number 2 was pressed, the start button was pressed, the equals button was pressed. That's our API. And then the controller is going to take mouse clicks and button presses and convert those into calls of the API. That's the controller's job. The model then updates its state. For calculator, it's updating the number that's being displayed. and then sends that to the view, or the view can ask for that, is typically the way that we have it. The view asks for the updated state and then displays it to the user. The user is going to see that state, react to it, and keep going around this loop. It really is a keyboard cat. Yeah. So our user's just walking across the keyboard in that example. So the model, I got ahead of myself a bit. This is most of what you've done, the code that you've written for classes. Like I said, I give you, for 116, my typical process is I give you the GUI, which is the view, and, well, I guess the GUI is the view and the controller, but I give you the GUI containing the view and parts of the controller, and then your job is to write the model. I tell you what the API for the model is. I say, here are the methods that you have to implement, because those are the methods that my controller is going to call, or my view is going to call to get your information. So all the button presses for calculator and microwave, and then display number displayed, display number, I forget what it's called, was accessed by my view, or get instructions in calculator or microwave was accessed by my view. So you had to implement those because that was the API for the model. And then however you implement those methods was up to you, but as long as they had the proper functionality that my controller and view were expecting. Importantly, the model has no idea that the user exists. It's getting calls to its API, and that's all it knows. It's completely removed from the actual user. And this is important for reusability of our code, as we'll see in a little bit. The view, it's output only. It's just taking the state of the app, and hey, I do expand these acronyms. Hey, there we go, chat. The view is only displaying the current state of the program to the user. I don't think there's anything I want to add to this that I haven't said already. Here. This is the big one I want to touch on. I'll talk about it right on the slide. So the view, since the user is disconnected from the model has no idea about the user. The model actually doesn't know or care what type of app it is. So we can use the same model, and you saw this in the chat app. We can use the same model for different front ends or different views. If we have the same exact app like we had for the chat app with a web front end and a desktop front end, we use the same exact model because we've decoupled the model and the core logic of the app from the way that a user is actually interacting with that app. So the model can be reused for any type of app. To change the type of the app, we write another view and another controller. So we write a new view, maybe we have a desktop app and we're happy with that and we used MVC and everything's decoupled, and then we want to convert it to a web app. Well, now we write some JavaScript, some CSS, some HTML that takes the state of the app, in our case typically JSON strings, takes that state of the app and converts it into a visual for the user to consume. And that front end can be completely changed, completely redesigned without affecting the actual core of the app, the model of that app. So if you want to convert Clicker into a desktop game, you want to build a desktop GUI, you want to get some practice with Scala FX, you can rewrite a front end for that and just have it parse that game state JSON string and then display all that information in whatever way you want to display. And your model, all the code you're writing for the Clicker homework assignment, aside from the WebSocket server, because if it's a desktop app, why have WebSockets at all? You could still have WebSockets, but you don't have to. You would write a new view that consumes that JSON string and then displays it in a different way, or whatever way you want. Or if you want to rewrite, as P says, if you want to rewrite my crappy looking front end with one with React components and really nice looking features, which students have done in the past. They've shown me, I've seen some really nice looking Clicker front ends that still worked with the same model. Everything that you're writing for the assignment, none of that changes on the server side. You just have a new front end that consumes that JSON string and displays it differently. And finally, the controller. This is what's handling user inputs. Typically our handlers in our code that's going to convert those actions. I press a key on the keyboard, I click the mouse, I speak into the microphone here, it's going to convert those actions into calls to the model's API. So if on the calculator, you click on the plus button, the model for the calculator that you wrote does not care that there exists a plus button. I mean, it kind of does just by the way we named the methods, but it doesn't care that a mouse was clicked on that button. It doesn't care if it was a touch screen and somebody tapped on it. It doesn't even care if it's a physical calculator and you embedded your software into this embedded system. It doesn't care. It just knows that a button was pressed somehow, whatever. I have to handle a plus operation being called for by some entity. It doesn't care. It doesn't even care if it's a unit test running and not an actual calculator and not an actual button press. We can simulate those button presses in our unit tests. The model doesn't care. And it shouldn't. That's a big advantage here. The controller does have to care. The controller's job is to convert whatever we actually have. Was this a tap on a screen? Was this a simulated button press? Was it a physical calculator? The controller is what's going to convert that into an API call and call plus button pressed or plus pressed or whatever we called it in the API. I forget exactly. So that's all the controller's job. We can validate the inputs at this point, or we can have the model validate the inputs. But whatever we're doing, we're converting those inputs, user inputs, into API calls of the model. GUI is the viewee, got it. I like that. The GUI's viewee. So we have a lot of advantages to this. Back when it was still a team project, this was a bit more important. You had a semester-long team project in this course. You should be, depending on how you feel, you should be probably grateful that that's not a thing, especially remote. Oh man. But when you have a team like that, you can easily split the project into 3 components. If you have a team of 3, somebody takes the model, somebody takes the view, somebody takes the controller. And as long as you agree on the API calls, as long as you agree on what the APIs are, especially the model API, then you can all code independently. You can all test your code independently by simulating the API calls actually functioning the way they're supposed to. You can what we call stub out. You can, if you're writing the view, you can stub out the model and just hard code a single state of the model and make sure it renders the way that you expect it to. So like if you're designing a new API or a new view for Clicker, but you don't have the model done yet, you just take a JSON string for a game state, a hard-coded one. You could even take the one from the homework document and use that for your testing state. Just make sure that state displays the way you want it to. You don't actually need a working model. So you can work concurrently with your other teammates, even though their parts aren't done yet and your code relies on those parts to work, you can still test independently. It really helps teams parallelize so you can divide the work and all work at the same time and not constantly be waiting on each other. So there's one big advantage right there, that you can work independently and test independently. The fact that you can update the view without breaking anything, strong advantage. We talked about that. The organization, of course, and easy to add new features, as we saw with the physics engine. Everyone says that I should add things for next semester, and often they just want to torture the next students. Group project homework for next CSE, and it was a big lab project. Whenever I had a project, like a third of the labs would all be work with your group and design things, and then demo to a TA for certain submissions, for project submissions. It took up a lot of lab time. You were working with a group, which it's not torture, it's discipline. It is, and I agree that you all need to learn that. I just think 116 is a little too early. You'll learn it in later courses. No. Yeah, only trade-offs, exactly, the real master. There's a lot of trade-offs between that. And on the web, your model is the server, your view is your HTML, CSS, JavaScript, And the controller, it kind of gets split between both. I'd say it's more so JavaScript, at least for the apps that I've given as examples. The JavaScript takes those inputs and converts them into API calls, but it converts them into WebSocket messages, and then the WebSocket server is doing the rest of the conversion to convert those into API calls, which would be, for Clicker, would be your game actor. Your game actor would be the model. I'd even argue that the actor messages are still part of the controller, which is why I recommend creating a separate game class and then having your actor convert the actor messages into calls to that API, and have a game API in the back end that would take clicks, purchase equipments, get the game state, update and get the game state, I guess. It would be your API. So we saw this in Jumper. The API are the button presses that a user can have, either presses, and the controller also remembered if you were holding down a button by seeing if it saw a button down event, it would track that as being held down until it saw the button up event. Then it would switch into up. And the API calls is this button down? Is this button up? And then the view takes the state of the screen, and the view does have a little bit of work here to do to decide which portion of the game should be rendered. So the model, when it gives up the state of the game, it actually gives up the entire absolute state of the game, which is every platform that has ever existed in this game, according to an absolute coordinate system starting at the ground level where you first start the game. It sends all of that to the view, and then the view has to decide where the player is in this global game to figure out which portion of that should be viewed on the screen. Which portion should we look at? Because you don't want to just keep zooming out as players are climbing up and show the entire thing. So the view does decide, okay, I'm just going to show the players this little window of the game, this little portion of the game. So it's kind of a little bit of logic. Maybe it's a little debatable whether that should be in the view or not, because it is a little bit of processing. Maybe we could have an API method that says, give me this portion of the game. But that's how the jumper works. Literally, game actor didn't need lots of code. Yeah, that's right. Game actor can be not too many lines of code. Most of the lines was probably in your JSON processing. We saw this in calculator. I've been mentioning this throughout, so I won't dwell on this too much. But display number, that's accessed by the view. The controller is converting those button clicks into API methods that you were implementing. And we talked about this before, but if you want to take a look at that grid system that I mentioned last time, we can talk about that. I mentioned all this. I got ahead of my slides a little bit there. All right, so that's MVC. Any quick questions on MVC before we talk about databases a little? A group project. We tried something like that. Group project in later courses to make homeworks for 116. We actually had a one semester, actually 2 semesters, where we tried collaboration between 115 and 442. 442 is an open-ended projects-based course. And we had 115 students testing those projects, cloning the repos, running their code, spinning them up, and then doing some testing. We didn't really get it working quite right. I feel like we missed the mark a little bit on that one. But I'm open to trying that again, doing some sort of cross-course collaboration. It might be easier in 116 than 115, now that y'all know a bit more about programming and computer science and engineering. But I'm open to stuff like that. I'm open to ideas. It's implementing them gets tougher. It's hard enough to pull something off in a single course, much less across courses. But I'm open to try again. So let's talk about databases. So we've seen this picture a bit. We have all the pieces of this filled in. You can do all of this except this little piece right here. So let's fill this last piece in so you can follow this entire architecture and you can build amazing apps using this this architecture. And you can fully understand all of the handout code, especially for the project contribution projects. Those use MySQL databases. We won't go all the way unless you wanted to talk about it next week. They also use Nginx and Docker. If you want to learn those, I have some optional descriptions in the project contribution document. If you want to take a look at those, and I'd be happy to talk about them next week. But MySQL is the last kind of, that's a hard thing to say, programming technology. The other two are DevOps things. I don't know if I want to make that distinction. So you've seen SQLite. This is what we used in 1.15, those of you who took 1.15 here. So you've seen MySQL is dead. So SQLite, MySQL is definitely not dead. It's more common to use something else for like startup companies and new projects, but MySQL is widely used out there in industry still. Personally, I like MongoDB. That's what I like to use for prototyping apps and playing around with code. But MySQL, it has a lot of advantages. So SQLite. What SQLite did was remove any networking you had to do. It created a local file on your machine in the directory of that project, and that was your database. And it managed a lot for you with that. If you just you started using SQLite and sending it SQL statements, it would create the database for you. It would, like I say, take out the networking. But really what SQL wants and what really any database is a server. So we have a database server that we have to communicate using typically TCP, but we don't have to think about that low level of the connection. But we connect to this server by sending it calls and using its API. So this runs as a separate process on your machine. MySQL, you have to download and install. It is separate software, and then that server runs on your machine and can be connected to by any of your programs, any program running on your computer. So we download it, install it, it runs as a separate process, and then in our code, when we run our code, we can connect to that server that's already running and send it statements. This is very similar to when we have the web apps and WebSocket servers. You have to run your server before you open your front end, and then the front end connects to your server. We're doing the same thing here. You have to install and run MySQL, and then run your program that connects to MySQL. So if you have a web app that uses WebSockets and MySQL, you download, install, and run MySQL. That's up and running. You run your WebSocket server. It connects to MySQL. And then you run your front end, or you open your front end in your browser, and that connects to your WebSocket server. So we can see a lot of moving pieces. And of course, all the communication between them. It's a big old event-based architecture. They're all reacting to events, which are messages from the other programs. So we have a big old event-based architecture here. Really, whenever you're using a database server, you have an event-based architecture. It sometimes doesn't feel like it, though. All right, yeah, I got ahead of myself. By default, MySQL runs on port 3306, and we're going to connect to it using a Java database connectivity library. So a JDBC, this is the standard way for a Java program to connect to a database. And of course, with Scala, we are under the scenes, behind the scenes, we are using Java. So we can use Java code in our programs, like we have all semester from time to time. So we're going to use that JDBC driver, which goes in Maven, install it through Maven. It's been in the POM since day one, and then connect to that. So we have to have MySQL running, install this, download this driver. It's not really a driver. I don't know. Is that the right terminology? But get this JDBC connector for MySQL, and then we can import that in our code, and then connect to it. Driver is the right thing, even when it's outside of. Yeah, we'll just go with it. I mean, I put it in the slide. It must be right? I would never have a mistake on a slide. Yeah, like, I mean, you can read it, but that's taking care of some of the networking. So we never have to think about TCP sockets here. That actually used to be the first offering of the redesigned 116. I did talk about TCP sockets, and we went there. We're not going there anymore. So the driver handles the TCP socket connections and all that, so we can focus on actually using this database. So to connect to this thing, we're going to have to give it a few things. The URL for the SQL server that's running. If we just use this string, notice we don't have any port number, it's going to assume that MySQL is running on 3306, port 3306. So we can assume that we just have the default install settings for that. And then this part, I had a strange bug. I'm not sure if you would even come up with the same bug, if you would have the same bug, but if you have this in here, you're not going to run into the bug that I ran into when I was testing all this stuff. It frustrated the hell out of me. It took me a few hours. This was the answer. Explicitly setting the time zone. So maybe you can go without that, but if you leave it in, it's not going to hurt. It shouldn't hurt anything. And then finally, your username and password for your account. I'm using the default root account. You can create an account for your MySQL database. In practice, you should. You shouldn't just use the root account. But for the sake of example, I'm just keeping it simple here. And then your password for that account, which is a password that you're going to set up when you install MySQL. MySQL is going to ask you to set a root password. And it's also going to give you options to be able to set up an account and create something other than the root account with restricted access. What case do we use that port 3306? You should never use 3306 because it's one of those ports that's pretty much reserved for MySQL. Like MySQL, when you run it, it's going to use 3306. So you'll connect to the MySQL server by creating a socket on port 3306. But that's, if you use that in your code, if you start a server and say listen on 3306, and you try to install and run MySQL, you're going to have some issues unless you change the MySQL port. But that's just going to confuse other developers, and it's going to be a mess. You would use it just to connect to MySQL. All right. So that's making the connection, and I gotta mention this bit of security. I have a password here in plain text. In general, this is very bad. This should never be your actual password, whatever password you have in your code. The danger here is that if you're checking this into a repository, anybody with access to that repository has your password. This is something that we really should not do. It's a horrible practice. This is partly what happened with the Equifax leak. They never changed their passwords. So like if you use my code here, my MySQL examples, the default password would be 123456778 with the intent that if you're going to use this code, you got to change that password. Equifax, they didn't do that. They just used the default passwords for some services of open source code that they were using. Well, everybody knows the default passwords for that, and somebody just tried the default password. They logged in and had access to all kinds of data. Horrible practice. And even better, the password can be stored in an environment variable, which is only on that system as part of that operating system, and your code should access the environment variable. And then when you deploy the app, you set that environment variable to your password, and then only people with access to that server have access to that password. Not anybody with access to the source code has access to it. Alternatively, you could deploy and then go into the code and change the password. That's a little less secure, but you can get it done that way too. Or a little less secure just because it opens the window for the people like Equifax employees to just neglect their responsibilities. And you might think, well, nobody's going to try. If I use the default password, nobody's even going to try to attack me. Well, there's bots for that. They'll just try every IP address. There are bots just going down every IP address and checking, hey, do you have anything listening on port 3306? Ooh, that's probably MySQL. Let me try this common password. Hey, I'm in. And then it notifies the hacker, hey, me, bot, beep, beep. I got someone you can attack. So it's not something you want to open yourself up to. It's not something you want to risk. And then finally, we're at the point where we can start using using SQL and sending SQL statements to our database server. So once we're connected, we ran all that code previously. We get that connection, the connection that we created using these values. Connect to it, and we're already connected. Sorry, and create a statement to be able to send to the server. And then execute whatever SQL code we want to write. That's how we're going to send a SQL statement to this MySQL server. And the MySQL server, as long as everything's set up right, should say, cool, I'm going to create this table named players with a username and points. When we want to send user data, of course, we want to use prepared statements whenever we're working with SQL. Hopefully you remember this from 115. If you don't, never use string concatenation to enter user information into a SQL statement. If I do insert into player's value, open paren, double quote, plus whatever the user gave me, I'm hard coding here, whatever the user gave me, plus, quote, comma, if you're using string concatenation, you're open to SQL injection attacks. And the next slide is about this, but I guess I want to talk about it right away. You're open to SQL injection attacks, and somebody can start writing their own SQL code that ignores what you're doing here and starts either getting data they shouldn't have access to, modifying data, just generally destroying your security, destroying everything you have. And so you replace the data, the places where the data will go, with question marks. This is the common syntax, which is true for JDBC as well. Replace it with question marks, and then set each one of them the values one at a time using set string, set int, set double, whatever the actual type may be, and giving it the index. So the first value, unfortunately, indices do start at 1 here. The first question mark is going to be question mark number 1. Replace that with the value Mario. Replace the second one with the value 10, and then we can execute the statement after it's been prepared and the data has been inserted into that statement. That way, even if this string does contain valid SQL syntax, it's going to be treated as just a string literal in the database. It's not going to be treated as part of the statement itself. So we're separating the statement, the code of the statement, and the data of the statement is what we're doing with prepared statements. And if you don't do that and somebody does drop table players, well, all our data is gone. We can't open ourselves up to SQL injection attacks. Luckily, it's a very simple thing to correct, to prevent. Just use prepared statements. If you're writing SQL code and you don't have question marks somewhere in that code, you're wrong. Make sure you're using prepared statements. Very easy to protect against these attacks and very simple to exploit these attacks. If you're vulnerable to it, any one of you could pull off one of these attacks. If you have access to the source code and you can study it, you can easily pull off one of these attacks and be successful. If we want to get information from the database, instead of just sending a statement to it for the database to execute, if we need information in response, then we're going to have to send a query. We're going to create a statement like we did, but we're going to execute a query instead of a statement and get information in the form of a result set. So the result set we can iterate over using this its iterator, which has a next method. You'll talk about iterators plenty in 250. But we can iterate over all this data and then convert it to whatever data types we want in Scala or what we expect. We expect username to be a string, so we're going to get it as a string. We expect points to be an int. We're going to get it as an int. I'm populating a map of strings to ints, so I know how many points each player has. And then after this executes, I have a map of string to int. We know what to do with that. We've been doing stuff like that all semester. But this is how you convert your SQL statement into a Scala data structure to be able to process any information you want. I'm going to get all of the data from the players table, and I'm going to add it into this map, then do any Scala stuff after that. But result dot next is going to get the next result. This returns true if there is in fact more data to read. So I'm going to say, well, there's more data to read. Process the next result. Is how we read that. Yeah, don't make your usernames tiny text to save memory. Users will get mad at you. Sub-users will. I forget how. Actually, I don't remember what the length of tiny text is, but maybe it's adequate. But I don't remember. And this slide is kind of my promotion for MongoDB because I like it. MongoDB is nice for prototyping. SQL is nice for optimal performance. SQL is based on these tables and columns. If you haven't really went into SQL more in depth, it's very similar to CSV. So if we want different types of information, SQL has lots of tools like joins, foreign keys, and things like that. It's a huge topic. We have entire courses on databases. You can explore that stuff. If you want a different way to do it, MongoDB is very similar to JSON structure and JSON organization. So if you want to use something that's more like JSON and you want to like that format and you want to stick with that, you can try out MongoDB. We're not going to talk about it in this course, though. And let's see if this worked for me. Okay. Oh, we didn't quite get there, though. And so there's this database code. If you want to run MySQL and you want to play with this, this is a good sample portion of code. It uses that the example that we saw earlier. All this code from the database, but a little bit extra. I do a little bit extra here. I thought we would get to the towers example, so I was really studying that one in preparation. But if you run this, if MySQL is running on your machine and everything's set up properly, this is going to work. If not, you're going to get this error, and it's going to say access denied right here. And everyone look away for a second. I'm going to type my real password. So I'm going to put in my real password for root. And now I'm going to get access to this database. I'm super secure, by the way. I'm going to get access to the database. The program's going to run properly. I'm going to be inserting into the database. I'm going to be pulling information out, and I'll get this text. So if you have MySQL completely set up and you run this program set up properly with the right username, password, and everything, the right URL, you'll get this output. You won't get any errors. So if you want to play around with it, and then once it's set up, then you can start working with whatever you want to work with. And for project contribution, if you do want to journey into bold territory and you do want to play around with database stuff and you want to test that with MySQL running, make sure you can run this first and then try to get that running with the project contribution projects. Get my password. You didn't think I could get a less secure password than 1234567 did you? Well, I got a less secure one. Don't use that password in real life, please. But if you hack this database and you destroy this information and this data, I'm not going to sweat it. I'm not going to be heartbroken. And the MySQL instance running on this machine, I'm only using it for 116 examples. So even if you are able to, get my IP address and hack into it, I'll be okay. I'll be all right. So we have 1 minute. Can I talk about towers in 1 minute? No, I can't. So we'll definitely talk about this Monday. Let's at least talk a little bit about this though. Oh, and my minute's up. No, we're not. I can't do it justice. But if you go to jessehartloff.com, you can play the game, and then we'll talk about it. Oops. Then we can talk about it some other time. So let's make that the end of lecture, and we'll talk about these MMO architectures next time. So we will have some slides next week. We'll have some more content for you.